As Andre said, my name is Frank Mignano. I've been involved with condition monitoring equipment and technologies for the past 25 plus years, the past 15 with SKF here in Houston. Here we have a little picture of the system that we're going to be talking about today, the wireless vibration transmitter. So a little bit about the agenda for today for the next 30 or so minutes. I thought it was appropriate for this audience to kind of cover the background of condition monitoring, how it is that we've gotten to this point where we're developing cool new technologies like the device we're talking about today. So a few slides on the background of condition monitoring, how we got to this point. Obviously, we're going to talk about the why we selected the ISA 100 wireless as a platform for this product. We're going to cover a little product positioning, capabilities overview, value proposition, and I've got a few slides on some real-life examples, some use case histories. I've got some pictures of a typical installation and a recap slide, and after which we'll field some questions. I think there's a way for you to send questions over to Michael, and he'll capture those, and we'll cover some of those at the end. Condition monitoring. So many years ago, back 60s, 70s, this was kind of the original definition of failure. We would put a piece of equipment in place, and we would assume it would last for 5 years, and it would run fine until it got old and wore out, and then it would fail, and we would change it out. So what they ended up finding out, and so in order to extend the life from 5 years to 8 years, we would implement some time-based activities. Typically go out and change the oil, maybe change the bearings, balance a fan, do some of these type of activities based on time in order to extend the asset life. And basically what they found out as they kind of dug into the details of this is the fact that most rotating equipment, the majority of failures are random in nature and not time-based. So this was kind of a revelation, again, back 1970s or so. And so when you look at this information and you try to determine how to cost-effectively maintain a refinery full of pumps and fans and blowers that fail randomly, the only way to effectively maintain those assets is by measuring their condition and maintaining them based on their condition. So these are some of the top condition monitoring technologies. Certainly vibration analysis, that's what we're going to focus on this webinar today. Foremost, if you're new, if you're building a plant, if you want to start a predictive maintenance program, you would typically start with a vibration analysis program. Excellent complementary technologies include lubrication, thermography, ultrasound, and even electric motor testing. Through vibration and electric motor testing, you can actually determine the mechanical health of the asset as well as the electrical health of the asset, which is becoming more and more important. So when we look at vibration specifically, we kind of, at SKF, and I think this is more industry true, we kind of break it into 3 different categories. So we start with a periodic group of machines or equipment that you would use to typically walk around, take a reading monthly, collect vibration readings, bring that back to a computer program, do some trending, do some analysis, and typically periodic is fine for slowly degrading machines or machines that have, fairly minimal cost impact to the process. We go from that end of the spectrum up to continuous monitoring, which is designed for your turbines and compressors that are extremely critical, perhaps unspared equipment that fail quickly. And on those machines, you typically put in an API 670 type protection system that's designed to trip the machine in milliseconds should something happen. So in the middle here, we have a group we call surveillance systems. And for the device we're talking about today, the WVT would fall into this category. So what the system does is allows us to get a lot more data than a periodic system and capture that information and bring it into the operations and maintenance side where we can use this information to plan outages. So one of the other points I wanted to make here was one common database. So SKF has a variety of portable systems, handheld systems. We have a bunch of different types of surveillance systems and protection systems as well. And all of these systems communicate to one common database. So again, why did we select ISA 100 wireless? This device, this WVT device, is actually our 4th generation device. It's our first ISA 100 wireless device. And some of the reasons that we selected that are included here. The backbone architecture, we just feel that it's the right design. We kind of liken it to, you know, when you're at your office, you plug into your network. When you plug into your network, you have access to databases, you have access to the internet, you have access to printers. Whereas, you know, in the old token ring days, you had to go from your computer to another through other computers to get to a printer or to get somewhere. So the backbone architecture is just the right architecture and fit in with what we were trying to accomplish with this system. Having said that, we also have flexibility in the design and the way we deploy these systems, because we can set up some of the transmitters and devices in the field as routers as well, so that we can go from one device through a device and back to the main backbone system. So that gives us some flexibility when we look to deploy systems effectively in plant facilities. Duocasting was a huge advantage that's unique to the ISA 100 wireless. And what this gives us is not only redundant paths, but true redundant signals for every transmission simultaneously. So we felt that that was very important, because that's going to help mitigate the possibility of losing data or having gaps in the data. The reason we're implementing these types of systems is because there is information in the field that we want to get back to where we can make use of it, whether it be temperature, flow, pressure, tank level, you know, corrosion information, and now vibration information. We're going down this path because this information is important and we want to bring it back. So the duocasting is very important, because if we have one failure point, we still have other ways to get this information back to where it's used. So of course that ensures reliable, and we're also interested in secure communications. As Andre said, there is, you know, 5 years ago there was a lot of concern, wireless, we don't want to do that. There's 1 billion+ hours on this technology these days. So it's no longer, you know, does this work, is it going to work? This is a fantastic system that's secure, reliable, and cost-effective to deploy. We like the fact it's scalable to support thousands of devices in the field. And there's some power usage advantages that we see with the ISA 100 platform that help us improve battery life. A little bit on the product positioning and overview. First off, we have a global alliance with Honeywell. So we developed this particular version with Honeywell's input. Honeywell is obviously well known in industry on the process side, the operation sides of facilities, with their control systems and leading edge automation packages. SKF is also a global leader. We're much more well known on the maintenance side of facilities. We're the global leader in rolling element bearings and magnetic bearings, and we've complemented that, supported that with a variety of support services, including our vibration analysis group. So we feel it's a good mix and a good alliance that's going to help both companies. So this device is designed, you know, for rolling element bearing applications where the reliability is critical to the safety and production goals of the facility. And one of the things we can also do is help mitigate the cost of repair, because the data that we're collecting is going to clearly show us when an asset starts to degrade, and we're going to have plenty of time with which to use that information to plan an outage. As you can see here, this is kind of the typical design. This is how we designed it, a WVT per machine train. Motor-driven pump, motor-driven fan, turbine-driven fan as well, agitators, mixers, transfer pumps, coolant towers. This is where we've designed this system. So one of the things I wanted to point I wanted to make is each of these sensors is actually a dual-purpose sensor. So we can measure vibration and temperature off of each one of these sensors. So that's also a nice advantage that we have with this system. I wanted to talk a little bit, if the machines have rolling element bearings, obviously SKF is very familiar with how to build and implement rolling element bearings through the use of our acceleration enveloping technology, which we have been using for at least 20+ years. We've been using enveloping for so long, our patent expired on this technology. So it's called acceleration enveloping. And I just wanted to cover very briefly what acceleration enveloping is, how it works. It's simply a signal processing technique that we use in all of our equipment. And out of an accelerometer, a vibration sensor, you're going to get typical velocity spectrum, which tells us the unbalance level, looseness, misalignment, some of the typical, vibration problems that you come across in the field. What we do with enveloping, acceleration enveloping, is we apply a bandpass filter, and essentially we're only looking in this area, and we're eliminating all these higher amplitude, lower frequency vibrations. As you can see, they're removed from this next slide. And what this does, in essence, is enhance our signal-to-noise ratio. So we're able to find these very, very low amplitude impacting that would be generated by a defect in a raceway of a bearing, improper gear meshing, and even lubrication issues. So what we're interested here is the time between these little bursts of energy, and that time between these little bursts is converted to the frequency. And if we know the bearing type that's in there, we can line up the frequencies with the inner race, outer race, rolling element, or cage. And we have a good idea of the condition in that particular asset. The target applications, as we talked about briefly, this is not for critical machinery. This is designed for semi-critical and balance of plant assets. When you look at a facility, the vast majority, as we're showing here, 98%, 90 to 95% of the assets in the field are in the semi-critical or balance of plant category. So that's where this system is designed to be deployed. A little recap of the capabilities of the Multilog WVT. It's an 8-channel condition monitoring device. So as we talked about, we have 4 sensors, but each one of those sensors will give us vibration and temperature. So that gives us 8 channels of monitoring. Plus we can also capture and measure speed. So that comes in handy. Everything in the vibration world, all the vibrations on the machine are related to the shaft speed. So being able to capture speed comes in handy on variable speed machinery. We need to know what the speed is when the data was captured so we can do effective analysis on the captured data. As you can see, it's battery or line powered. Again, designed for rolling element bearings, semi-critical, balance of plant machinery. One of the things I said, this is our 4th generation. One of the things couple things we really wanted to affect on this new design. One of them is the battery life. And so what we did is we specially designed these sensors to be very low current draw. The typical sensors that are used in industry, typical accelerometers are in the order of 4 milliamps for a draw. These sensors are below 100 microamps, to give you a kind of a feel for what we've done with that. And our engineers are fully confident that we should be able to get better than 5 years battery life out of the system based on recommended settings. Again, it's an engineered drop-in solution for an a Honeywell ISA 100 network. It's Class 1 Division 2 rated by CSA. And it's also good for low and high frequency vibration situations. So if you have a low speed roll turning in a paper industry or high speed multi-stage air compressor, we can capture that information accurately because, as you can see, we can go down to half a hertz or 30 RPM all the way up to 15 kilohertz or 900,000 CPM. So we can handle a variety of applications with this technology, variable speed and low and high frequency applications. This is just a overview of the components, the main components that make the system, the integrated solution. Here we see the WVT, obviously, wirelessly communicating back to the Honeywell One Wireless infrastructure. Two main components on the Honeywell side is the FDAP, they use acronyms as well, Field Device Access Point, and the Wireless Device Manager. So the Wireless Device Manager is kind of the CPU of the system, the brains of the system that helps manage things. But another key point I wanted to make off of this slide is that we've got dual data paths coming out of the WDM. So it was important to us to involve operations. We thought that getting this information is key, but also getting it to where the operators could use it and help to improve the reliability of the site was a good thing. So we can send some overall information over to the operators, and then we can also send that overall information along with the detailed analysis information to the SKF software. Again, just a little bit more on each device. 300-meter line of sight range between the devices gives us a lot of capability, a lot of flexibility there. Again, the WDM kind of manages the ISA 100 network, the Honeywell version. It's a security manager, allows you to design, commission, configure, update all the components in the field. And the field device access point, as you see, can be set as a router to give us that added flexibility when we need it. So this is just a schematic of what a typical system might look like, where we have the WDM, which kind of controls everything. We've got the first FDAP is a wired FDAP, and then we can have wireless FDAPs out in the field, strategically located to give us site-wide coverage. And then we see the Multilog WVT devices that can communicate all back to one device and on through, or again, in the routing mode, we can go from our device through another one of our devices and back to the FDAP and on into the WDM system. So as we talked about duocasting earlier, basically what's happening here is that we have a main path that we can see on the system, but we also have redundant paths which allow the redundant signals to be communicated simultaneously. So the beauty there is that if we happen to lose one particular device, say this particular FDAP happened to fail, we're not going to miss a beat because that same data is already going a different path to get back to the system. So just a little example of the duocasting that's going on within the system, behind the scenes, if you will. So we can get all the scalar data back to through the WDM. We can send it out via Modbus or OPC to the data historian. We can get that same information along with the analysis information back to the SKF software. So this just simply shows a little screen from the SKF software, actually. So the way these systems work, and it may be a little review for some folks, but you have a one wireless system out there, and you open it up to go look for new, as you install new equipment, you open up the system to look for new ISA 100 systems. Once it finds them, then you take and okay them, you accept them, you provision them into the system. Once that happens, our software will go and find that data that's being generated, and it'll automatically create the hierarchy in our software, and it would look something like this. So this is automatically done, and all you would need to do at this point is to come in and change the serial number, WVT serial number, to the actual asset that the machine is on. Pump number 1, 2, 3, channel 1 becomes motor outboard, channel 2 becomes motor inboard, 3 is pump inboard, 4 is pump outboard, something like that. So then you can change the name so that you know which machine you're looking at. So it's very simple, it's automatic, and it's automatically generated. It's a nice feature. Again, we have the graphics package that we can also send this data to for display and trending. So each of these sensors, the way the system is configured, we can get up to 5 different PV or overall values off of each sensor. So the first one is the bias voltage. Obviously, we want to know if the sensor's good, if everything's okay. That's key information. We don't want to be collecting bad data. Since this is an accelerometer, We can measure straight acceleration off the sensor. We can take that accelerometer signal and integrate it to get velocity. And then we use our signal processing technique on that signal to get acceleration enveloping. So acceleration is going to measure the force on the machine. Vibration velocity is a standard in the industry for the past 35 years. There's ISO standards on good and unacceptable levels of vibration based on vibration velocity. Enveloping is the SKF method for finding bearing and gear defects as well as lubrication issues. And of course, we're going to be able to monitor the surface temperature as well. So off of each sensor, we can get 5 different parameters telling us a little bit about the asset. 1 week trend plot based on recommended sendings, which is once an hour. We're going to have 168 data points over a week. So we can get all this information. All this is available to be sent to the DCS. And in addition, we can get all this information to the SKF software as well as the detailed analysis information. So we see we have acceleration FFT. FFT stands for Fast Fourier Transformation. There was a French mathematician, Jacques Fourier, back in the 1700s that thankfully did all the math for us. We don't have to worry about that, but basically he converted the time base to a frequency base. And so we've ended up with a fast Fourier transformation. This is simply a time waveform, the raw signal coming off of the sensor. So we can get an acceleration, we can get velocity, and we can get acceleration enveloping FFTs and some waveform information as well. So though it's one sensor, we can process that acceleration signal, integrate it, and then do our enveloping magic to allow us to learn more about what the condition of the machine is. The value proposition. There are many ways, ways that this system provides value, and I think one of the key ones that we see in the industry, SKF is in the predictive maintenance business. We have a service group, over 100 service guys around the country. That's what they do. They go out and collect data, manage the analysis of that data. So with a system like this, and what we're seeing is, you know, there's in industry and ourselves as well, insufficient manpower. You know, people end up retiring, they take vacations, you miss opportunities to collect data. With a system like this, easy to deploy like it is, the data collection is automatic. So rather than having to go out and collect data, we can spend more time analyzing that data and making corrective actions to the issues that show up. The other advantage, since the sensors are permanently installed, the data is much more repeatable, which is a big advantage, especially if you have several different people collecting portable information. There's a significant reduction in the cost and the time to implement a system like this. It's simply mount 4 sensors and mount the WVT, come back and provision it into the WDM system. It's a very easy to deploy as a temporary tool. This is a fantastic advantage because over the years I've seen in industry, somebody will have a machine that's all of a sudden making a funny noise and it's shaking quite a bit, and they have an outage coming in 3 weeks. And so first thing the Vibe guy will do is he'll come in 7 a.m., go run over there and take a set of readings and see how it's doing, see how it's done overnight. If it's any worse, what do we need to do? Do we need to shut this thing down? With a system like this, you can simply walk over and put the sensors on and have it start storing data once an hour, so that when the guy comes in the next day, he's got 24 data points to look at and some analysis plots to look at as well. So he doesn't have to spend time going over to the machine. The data is already there at his computer. Fantastic deployment for this technology. So added value of a walk-around program, again, best practice is collect vibration, full vibration on your rotating assets once a month. In some instances, maybe it's a little more critical. You determine you want to get it bi-weekly, twice a month. And so even when we collect this information, at times there are machine upsets. Rotating equipment is a very dynamic proposition. And we're processing fluids and moving things around the facility, and process upsets happen, valves get closed, we kind of beat up the machines a little bit, and we maybe lose lubrication to the bearings. Different things happen that cause upsets and cause events like this. So with a system like the WVT, we're going to be able to capture this information. We're not going to miss it because we only took readings every 2 weeks. We're going to have 168 readings every week with which to trend and look at and review. Huge advantage. Collect data when the machine is running, actually. So, you know, we see this as well out in the field when, you know, a guy, he'll get to his route and he'll get over to that particular machine and the machine's not running. And so it's a missed opportunity to collect data and determine the health of that particular asset. So with a system like this, when the machine's on, we're going to capture data. When the machine's not running, we're going to capture that data as well. And it's clearly going to tell us that the machine was not running. This is a great trend plot. This is exactly why you would invest in a system like this, because what we have here is a 7-month trend plot. And for the first 3 months, there was relatively no change in either of these plots. The subsequent 4 months, we saw a significant change in both of these plots. The top plot increased by a factor of 4 over these 4 months. The bottom plot increased by a factor of 7. This is, again, our acceleration enveloping measurement on the bottom, straight acceleration on the top. So you take a look at these plots, and this is exactly why you'd be investing in this system, because now we've had 4 months with which to plan an outage. We know that something is failing on this machine, and it's failing slowly. Typically on a rolling out bearing application, this is what you would see. It's not a very quick failure. We're going to have time, we're going to have the data, we're going to have time to take this to the maintenance planner to schedule the repair, the corrective action. So this is just a great trend plot here. Another application is, you know, guys, when they go out and they do repairs, these, in this particular application, there was a repair, quote unquote repair, done on April 20th. And then they went back, they fixed the machine, and then they fired it up. And clearly, they may have fixed what they set out to fix, but they created another issue. And all of the trend plots had a significant step change in levels. So we could see very clearly that while they may have fixed something, they now need to go back and fix it again. And this is good information to have as you manage the assets and the health of the assets in your facility. And again, it's automatic, it comes to a database, and we're set up to just kind of review the information and make decisions based on the data. There's obvious cost savings versus cabled instrumentation, not only the materials, the conduit, the cable trays, the wires, the cost of putting that type of system in, but the ongoing maintenance costs and grounding issues and you know, the seals in the conduit that go bad, and you know, your conduit fills up with water, and then you have to deal with those types of issues, ongoing issues. Those all go away with the system that we're talking about. This here is just an example of the potential for cost avoidance. Some of the things that this type of a system would affect. And again, minimize repair costs. That trend plot we just looked at. They had that information that vibration was climbing, slowly climbing over months. They could have went in and maybe balanced the fan, or changing bearings rather than changing a bearing, a rotor, a stator, a coupling, you know, the potential for injury, obviously, or product leaking. And production is huge. Losing production can cause lost opportunities for certain manufacturers. You can't meet the delivery, maybe your customer finds somebody else that can. And safety in some industries is critical. In the chemical industry in particular, of course, can be significant issues when machines fail that are pumping some of the more nastier fluids. So again, this is just an example. Give you some ideas of how this system can help mitigate and address some of these types of losses, or help improve the situation. Cable installations costs. This is just a quick calculation covering some of the labor and materials to run 100 foot of instrument wire, cable tray and whatnot. So this is just a typical install, and again, the wireless BT device here mounted And this is actually on a motor agitator on top of a tank. And so we're kind of up in the air. We're 30 feet off the ground at this point, and this is where some of the FDAPs were located. So we had very, very good communications back to the network and back on into the system. So typical installation: a couple of sensors on a motor. These are mounted down here in the load zone of the bearings. A couple on the driven component as well. This is the One Wireless, the WDM application interface. So there's a selection panel, ribbon bar, map view, property panel. I guess the point we wanted to make with this slide is the fact that you can see our device shows up within the Honeywell application, and you can modify, you can configure our system through the Honeywell application. Change storage intervals, frequency ranges, things like that. This is just kind of a real-life example. Using Google Earth, you can capture a photo of your facility, import that in here, drag and drop some of the devices out into the field. The system will automatically create these lines and let you know what the signal strength and signal quality is. Again, we can kind of make some changes to the settings and storage intervals and things like that within the Honeywell application. Again, this is the a typical graphical user interface, and the data would be available for operations or process engineers or whoever can pull this data up out of PhD or PI, or the data historian information, to look at what's going on with these particular assets. As a recap, the SKF Multilog WVT is an ISA 100 wireless device. It's 4 sensors, but 8 channels plus speed. We do have wires from the sensors to the device, but those wires give us a little bit of flexibility when we look to deploy the technology. We can measure speed, which is critical on variable speed machinery. There's a little local display on the device and a little button on the side, so you can actually walk up and get a little bit of information, such as the current values, signal strength, battery level, different things like that. It's a NEC Class 1 Division 2 rated system. We have a wide temperature range for the sensors, -40 to 120 C. We can put those sensors on the bearing. Wide temperature range and a wide frequency range as well. We can handle both low and high frequencies. Honeywell provides the wireless expertise, while SKF provides the vibration expertise on a system like this. It can be battery or line powered, and they're commercial off-the-shelf batteries for this system. So that means you do not have to buy batteries from us. These are available online, and and it helps to bring the cost down. Non-proprietary battery power. 300-meter inter-device range. And so with that, I think we have a little time here for some questions.
Yeah, so any of the participants who have questions, just please use the Q&A tab. It's at the right-hand side of your control panel in the center of your screen. It's the first one up there. It says Q&A. We do have a couple of questions already. So let's see. Some of them have to do with configuration. First, I'll mention that this webinar is recorded, and so the slides will be available on our website either later today or tomorrow, as will the recorded version of this webinar. So that's a bunch of good questions. So if you wanted to take on more than 4 sensing locations, how hard is it to expand? Can you just add more sensors, or do you need another multi-log? I guess we're looking for a description about how these things can be configured and expanded.
Yeah, I mean, the expansion would be an additional multi-log kit. So each multi-log will handle 4 of those dual-purpose sensors, and if you needed more, like another asset, you would need another WVT device or a kit with the sensors and cables.
Yeah, there's a related question. Do you need more than 1 unit for each piece of equipment?
It would depend on the piece of equipment. A typical motor pump, you probably would be fine, but in that example that I showed the photo of, that was a fairly complex right angle gearbox, and I would feel more comfortable with probably a few more sensors on that particular machine. So it'll really depend on the application, and that's where SKF would come in and kind of look at your assets and make that determination as to how many sensors would sufficiently provide the coverage on that machine.
Yeah, and so here's another configuration question. It says, do you need one unit for each piece of equipment? I guess they're asking if you had one unit, can you have 4 of the drops and have 2 going to one piece of equipment and 2 going to a different one?
You can, and yeah, so that's what I was referring to, talking about the flexibility. We do have sensors, but we have flexibility, and we can handle up to I think a 20-meter cable, so 5, 10, and 20-meter cable. So 60-foot cable we can run from the WVT to the asset. And so we can put 2 on, one machine train and 2 on another machine train, Again, we would be involved in that discussion and determination, providing our experience and input on the particular assets and whether that would provide sufficient coverage. But yes, you could take and put 1 sensor on each of 4 pumps as well.
All right. And somebody's asking, how is the GE value measured?
The GE value is again, the value is GE's. that's the engineering units, but it's a filtered acceleration reading. So it's not a straight acceleration; it's filtered, so the numbers tend to be smaller. We have some standards on that as far as acceptable levels.
So
the trend, yeah, and really the trend data is what's important, because we're gonna by having that information, 168 measurements every week, we're gonna have very clear indication that things are changing and heading in the wrong direction. As in the example we looked at, we had 4+ months of climbing levels, and that's really going to be one of the keys to identifying issues.
Right. And there was another question about, I guess it was about data loss from signal interference. And I'll answer that question. The ISA 100 standard was designed specifically for harsh environment, industrial environments. So between dual-cast and other coexistence characteristics where it's getting radio interference, it's proved to be very reliable. We are going to publish a study that was done at a steel fabrication site, and it showed almost 0 packet loss over a course of 6 months in a very harsh environment. So it's shown to be reliable. This was independently done by end users. And so this will come out in another month or so, but packet loss and data reliability is extremely high with ISA 100. The absence of packet loss and the data reliability is high. There was another question. One of the participants, so he was asking a question about doing a pilot with this with your application. So the question was, can the technology be piloted without going through this WDM? In other words, removing the security concern to a pilot program. So I'm guessing that he's wanting to do a pilot where the application can be run standalone and not connected to the rest of the network.
Separate from the site network, certainly, yeah. We've got to, yeah. We just need those components, those main components, the WVT, the FDAP, and the WDM. We have to have those 3 pieces, and we could send the data to a laptop. So I don't know if that's a question or.
Yeah, I think it does. The WDM is manages a security manager and system manager for the ISA 100 field device network. And so on the high side of that, Ethernet can be connected to anything, a laptop or backbone network. So yeah, you could set it up standalone. Let's see, another question. Can data parameters like Fmax, LOR be changed dynamically from a workstation?
The Fmax, you need as well. Again, this is more from the. Yeah, you can do it in two ways. We have an application called Data Controller. So if you wanted to change it permanently, you would change that in the Data Controller application and then send that back out to the instruments. If you wanted to just change one parameter, it'd be easier to do it through the WDM, and then you would just need to be at a machine that could access the WDM application software. So whether that's on the network, I'm a little fuzzy on networks, but sounds like it should be doable.
So what's the point-to-point range of wireless devices?
You know, as we showed, it was with the antennas that come standard with the Honeywell FDAPs, we're looking at 300 meters point to point. So from the WVT to the FDAP, we can go 300 meters line of sight, 900 plus feet.
Right, and I've seen high gain antennas that go closer to a mile. In fact, we're going to do a presentation on such a use case. And so there's a question, does this use IEEE 802.15.4 radio? The answer is yes, and it has some modifications like duocast to make it a little bit better for industrial environments. So how often can you transmit the analysis information, the waveform, versus the overall values?
The recommended setting is once a day for sending that information. So again, it's going to come down to how big of a file, how many lines of resolution that you're looking for, and the frequency range. But it can be improved. We can get better than once a day, but that's our standard setting. And if you look at the way we're deploying the system, we've got all these overalls that we're going to collect once an hour. So over a 2-week period, where typically if you're taking a lot of portable data, you're collecting every other week, and you're getting one data point. With this system, we'll be collecting data every hour, and we'll have 320 data points in that same time. So we're going to have a lot more coverage from the overall settings, and over that 2-week period, we'll also have 14 FFTs to look at as well for each of the measurements at once a day. So, you know, I know when I talk to some of the process people and the Honeywell folks, that update rate is, you know, they're kind of used to the millisecond and, you know, couple of second update rates. And in the condition monitoring world, that's just not necessary. Due to the assets that we're targeting with this, rolling out bearing machines are not going to fail that quick, and collecting overall information once an hour and the detailed analysis data once a day, we feel is going to provide more than enough information with which to analyze that machine.
Right. And is this application or technology licensed for operation in Qatar?
I'm not sure what you mean by licensed. We are waiting on an ATEC certification, if that is a barrier for that part of the world, but you know, it's on the 2.4 gigahertz range, which I think is a free band in most places globally. So I'm not exactly sure about Qatar.
So also a question about the FFT data. Can you export it to other software package, or does it have to be analyzed in SKF software?
Yeah, I mean, this is an SKF system, and you know, we like to bring that information into our software. We haven't thought about making it available to other programs.
Okay. There's a question of what type of tack is used, or is it a process or an implied speed from the sensor?
We have a NAMR rated sensor. It's just an inductive sensor that you would put near a keyway on a shaft that would give us a once per rev signal, so that on the variable speed machine, and there's a little bit of work mounting that. You'd need to create some sort of bracket that would get that sensor near the shaft, or a multi-tooth gear would work as well. So once that's in, we can capture the speed and then capture the vibration, so we know what the machine was turning at when we try to analyze the detailed spectral data.
Okay, thanks. There are several questions about cost of the system. So I don't know if you're comfortable about talking about cost or pricing in this forum, but if attendees want detailed cost information, they can email Frank, and I'm sure he'll be happy to talk to you about it. So here's his email. It's on the slide.
Yeah, I'm just not sure who exactly is on the phone. So yeah, send me an email. We'd be happy to work with you and talk to you about the technology. But actually, and just one thing I will say is, with all the information that we can get off of this box, off of one of these boxes, we have the 4 sensors, which are dual purpose. We process it in a lot of different ways. We're getting over 40 measurements off of this instrument, or there's a potential to pull 40 measurements off of different measurements off of the instrument. And when you look at it that way, we're down in the couple $100 a point range or less.
Okay. I'm looking. Yeah, I'm looking. Are there other questions that you see, Mike? There's a question I'm not sure about, but essentially it's asking how does these measurements and this system handle contradictions with alarms?
I'm not really sure, because with this system, so we have the dual data paths. We can take this information, send it to your DCS, and then you can set alert and danger set points over there. When it comes into our software, we can do the same thing, set alert and danger set points. So I'm not sure if that answers the question, but
yeah, I'm not sure either. It's possible that the question. Yeah, I'm not sure. Okay, here's a couple of other questions. Can you use 8 accelerometers if you don't take temperature?
No, because the system's been specifically designed to improve battery life, and it's so that we need to use the specific sensors for this system. These are the only ones that'll work with this system. Mm-hmm. Because of the low current draw.
All right. There's a question, I guess it's related to signal distances. One of the attendees is asking what antenna options are available on the WVT.
You know, we've picked a pretty standard antenna, and we haven't found a need thus far for different types of antennas. So I'm sure our engineers have done work and looked at the different options, and we also work closely with Honeywell. So basically, I think any antenna that works on the FDAP would probably work on the WVT as well, if there was a particular need. But you know, if the system is designed properly, there should be no need to worry about it. Different antennas. The one we provide standard is going to work fine.
So can you trigger a waveform collection based on the overall value exceeding a limit?
Not currently, but that's a good idea. I mean, it's designed, again, one of the big things was battery life, making sure that this would go out and live out in the field for 5 years. So in order to improve battery life, you have to, limit some of the capabilities. So right now, there isn't any trigger function built in, but it's something we have talked about.
Great. And you answered the next question about what the typical battery life is, so we're okay there. So
which again, our engineers feel confident that we should get 5 years, and the batteries that we use are the same ones that Honeywell uses in their vibration and temperature transmitters as well. I mean, they're temperature and pressure transmitters.
Mm-hmm. Okay.
Great questions.
So I'll remind everybody that the slides and the Q&A, it's all being recorded, and so it'll be available on the website in a couple days. We're getting to 5 after the hour, so I think a lot of folks are starting to drop off. But there's one last question. Would you sacrifice resolution if you're collecting more waveforms than once a day?
I don't. There is a limit on how much, because obviously the overall data is a date and it's a value and a timestamp, so it's fairly it's not a lot of memory, it's not a big file. The FFTs will take up a little bit more, so and the time waveforms, but I don't think you will need to sacrifice significantly if you increase the frequency of the FFT storage. But again, I don't think really that's the purpose of this system. Is we have other systems where you can monitor and change things and get data back, but this system, again, with 168 overalls a week and some FFT data, I think we're going to have sufficient information. And one of the things that we are actually working on is looking at the system, looking at the data, and requesting a data set, having a little push button where it goes out and just collects that data right then. So there are things like that we're looking at to help improve the capability and functionality of the solution.
And one of the things that I'm aware of with the sensing devices that use FFTs or waveform data, there are several that are ISA 100 compliant, and all of them are using the ISA 100 network to move the data back to it. The ISA 100 network has got the capability to push the large data sets through, typically one a day. I see other configurations, both with ISA 100 and with other technologies, where these data sets are sent through a backhaul, like over a Wi-Fi network, to pick up the larger data sets. But this is very straightforward. It goes through the ISA 100 network, and it's because of the technology in ISA 100 that allows it to do that. Okay. Any last words, Frank? I think we need to wrap up and give everybody their day back.
Yeah. Thank you. I just want to say thank you very much for the opportunity to present. If anybody does have any specific questions, send me an email, give me a call, and we'll talk through it. We'd love to work with you guys, talk to you about possibly implementing this exciting new technology.
All right. Thank you, and I thank all the attendees for taking an hour out of their day.
Yep. Excellent.
Bye-bye.
Bye.